Did you know that 2 optical fibers, the thickness of a human hair, can transmit 625,000 telephone calls at the same time? Did you know that a champagne cork is completely airtight? Or that to ensure greater performance, golf clubs use plastics reinforced with carbon fiber? Have you heard that stainless steel, titanium, and certain metallic alloys are used to replace joints in our body? Take a few seconds and look around. The car you drive, the computer that puts you in virtual contact with the world, the plane that makes this contact real, the radio, the television, the mobile phone you couldn't live without, solar panels and wind towers, microchips and skyscrapers, your glasses, your favorite item of clothing. We live in a world that is both dependent on and limited by materials. From nanoscale to mega projects, modernity requires products that are ever lighter, stronger, cheaper and cleaner. And meeting these demands requires advanced materials and new manufacturing processes. Materials are the infrastructure of technology. Materials engineering is the key and the engine for a change towards more innovation and a better quality of life. The Stone Age, the Copper Age, the Bronze Age, the Iron Age. The ability of man to apply certain types of material was used to classify prehistoric eras. One of the most significant milestones occurred in the mid-19th century. The Industrial Revolution brought a boom in metallurgy, which for many decades was at the heart of materials engineering. Yet at the same time, there was another breakthrough at the hands of Josiah William Gibbs and his phase diagrams. A valuable contribution that laid the foundations of knowledge in this area, allowing us to act on the structure through processes which change the phases of substances, resulting in specific properties and performance. And these relationships became established through the characterization of materials. From great transformations with intervals of centuries to new concepts introduced at the speed of light, today, instead of relying on the discovery of new useful materials, this engineering of the future analyzes the raw materials in their deepest essence. It understands them and knows how to manipulate their properties. It designs new materials in accordance with the needs of each and all of us. In construction, in the automobile industry, in communications, in health and sports, in energy and the environment. Materials engineering is everywhere, and academic progress in this area has led to the creation of new products, resulting in new industries. Leading the change, a group of professionals with a mission to transform matter, designing and building a more creative and intelligent world, more sustainable and more comfortable, more open to everyone. Materials engineers center their action on controlling performance by optimizing the internal structure of matter. Their focus is on the final product and its application. Combining several areas of knowledge, they investigate the structure, properties, applications, processing, and performance of new or existing materials. Materials engineers are present in all stages of the processing cycle, from the selection of raw materials to the finished product. They are essential in the manufacture of tradable goods. They take part in the project stage, supervision and quality control, in the investigation of causes of degradation, and in making proposals for solutions or alterations in the industrial process. Engineers in every sense, transversal, multidisciplinary and innovative, with a modern-day Midas touch, who transform what exists around us into a universe without limits. Physics, chemistry and mathematics are the basis of the training. Then more specific areas such as thermodynamics, crystallography, mechanical, electrical, optical and magnetic properties, materials processing and product design. The profession requires broad and interdisciplinary learning, and on the curriculum, solid notions of chemical, mechanical, civil and electrical engineering, as well as micro and nanotechnology. A technically very demanding area, and Portugal is capable of producing the best professionals. The Portuguese Engineers Association makes every effort to ensure the solid goals of rigour and quality are met in higher education. The development of materials is not only done in schools of engineering, but also in research centres, which boast a scientific community with levels of productivity among the highest in the country. A profession expanding fast and a labour market that rapidly absorbs these professionals. Materials are the infrastructure of technology present in everything to serve human interests and needs, and to optimise their performance is and will continue to be in the coming years one of the areas of greatest investment in the world. In Portugal alone, the tradable goods industries based on engineering materials generate an annual turnover estimated at 25 billion euros, employing around 1 million people. New technologies developed in science and engineering will continue to make changes in our lives, and materials engineering is the key to this change. In the future, these professionals will be responsible for developing and applying materials to withstand higher temperatures for use in hypersonic transport. Materials with faster performance for applications in the electronics industry. Eco-efficient materials and manufacturing processes that save energy and preserve the environment. Materials for life sciences that are biocompatible and promote tissue regeneration. Today, more and more, these are the challenges for this engineering in the future, transforming matter into a new world closer to our dreams.